Hello, ladies and gentlemen. Welcome to Chemical Composition and Reactions Oxidation Numbers, Part 2. Okay, first off, I will be sending you a copy of this periodic chart so that we have standard information as far as which oxidation numbers to be using. I will be sending it through OneNote. In fact, you might already see it there under handouts. I will also be sending it by email to make sure that you have it. Okay, last time we talked about how to determine oxidation numbers by some rules. If you take a look at the periodic chart, you will notice not all of the elements follow these rules, especially this transition metals section right through here. And some of the others up into the nonmetals and metalloids. They tend to have a lot of different oxidation numbers. So what you will need to learn to do first off, now that you of course know the rules and have them memorized, is be able to determine what the oxidation number is inside of a compound when you only know some of the oxidation numbers. Okay, for example, if you have Na2O, sodium monoxide, okay, we know, let's say, that the oxidation of sodium is a +1 because it's an alkali metal, so it's in that group 1. Let's say just because we don't know the oxidation number of oxygen and we need to figure it out. Well, first off, in looking at the formula, you can tell that we have 2 sodium ions that each have a +1 oxidation number. So if we look at that as a total, we know that sodium has, with both ions, or both atoms, the oxidation number of +2. Because of the zero-sum rule, we know that whatever oxygen is, when it is added to the sodium atoms, it must equal 0. Okay, now I only have one oxygen atom. So in order for it to equal 0, we have a +2 for the sodium. Whatever oxygen is will need to be a -2. And because there is only one of them, I hope you can do the math, 1 times something equals a -2. The answer I'm hoping you would get is a -2. Okay, so you just go through it step by step. Now you should have already known that oxygen is -2 because that's one of the ones you're supposed to memorize. And you should be able to tell sodium is a +1 because it's an alkali metal. Now, nitrogen and oxygen make up a lot of different compounds together. So the question is how do you know what the oxidation numbers are? Well, the difficulty is that nitrogen has 6 different oxidation numbers. Now, we know the oxidation number of oxygen is -2. But the question then is which oxidation number of nitrogen is being used? Now, if you know that oxygen is a -2, and you know it needs to add to a 0, you should be able to eliminate one of the oxidation numbers immediately, and that is the -3, because a negative and a negative in no way can add together to make a positive, or a 0 in this case. Okay, so let's go through each of these different compounds containing nitrogen and oxygen and see how it works out. Okay, first off, let's look at nitrous oxide, N2O. Again, we know oxygen is not a +2, but is a -2, as is written there. and we know that it needs to equal 0. Okay, we can look at this. We know we have 1 oxygen. It's -2. The total is -2. Not too complicated. Nitrogen, we know, has to also equal a +2 so that we end up with 0. And we know from the formula that there are 2 nitrogens. So again, we have 2 of them. We need a +2. Therefore, the answer is a +1. And we can tell that in this case, the oxidation number of nitrogen was +1. Okay, so what happens if we have nitric oxide, NO? Okay, oxygen is the same. It is a -2 in spite of what it says on the left side. And we know that we have 1 of them. We know it needs to sum up to 0 when we add them together. And we also know that we have 1 nitrogen in this case. Now, if you have 1 of them and it needs to equal a +2, that means that the oxidation number of nitrogen is +2. Okay, so you can see even though it looks simpler, it actually has a higher oxidation number. Now remember, the oxidation number just means how many electrons can either come, go, or be shared by an atom. It's not the charge. Okay, next one, dinitrogen trioxide. It looks more complicated. N2O3. Now this time we have 3 oxygens, each with a -2, which makes a -6 oxidation. At the same time, we know they're going to equal 0, so we know that the nitrogen has to be a +6, and we have 2 of them. Now, if you have a +6 and it's divided by 2, you hopefully will be able to get the answer that the oxidation number of nitrogen is a +3. Okay, let's move on to the next. Nitrogen dioxide, NO2. Okay, we have 2 oxygens to make a -4, sum 0 rule, and we have 1 oxygen that has to equal a +4. 4 divided by 1, hopefully you all can get that it should be a +4. And I'm hoping you're starting to see the pattern here and how things go together. Okay, the last one in the list is dinitrogen pentoxide, and yes, you too will learn how to name these. In this compound, we have 5 oxygens, each at a -2, to make a -10. Okay, we know they have to total up to 0. And in this scenario, we know we have 2 nitrogens. Okay, so you have a +10 and you have 2 of them. Okay, hopefully you can do the math here. It's not too hard. And you should get that nitrogen has an oxidation number of a +5. Okay, so just because nitrogen has 6 different oxidation numbers and oxygen only has the one that we're going to worry about, you can realize that depending on how they combine together, you can get lots of different answers for what the oxidation numbers of nitrogen should be. And you should be able to figure out which oxidation number is being used by the nitrogen depending on what the ratio is in combination with the oxygen. You will have these in your homework, So make sure that you don't just try to look up the answers, make sure you understand so that you can do them. Hopefully you realize it's not that complicated. Just use the periodic chart that you're given and you should be able to do this without any problem.